Lesson 34 is about the greatest common factor, and the problems that we have are going to look like this. What we have to do is find the greatest common factor, or GCF, of, and then we've got this expression. We have 8z to the fourth m squared p minus 12z cubed m to the fourth p squared. Now before we find the greatest common factor of this problem, I want to go through greatest common factor with just some numbers, no variables. Let's say we want to find the GCF of 8 and 12. We'll take two numbers. So if we want to find the greatest common factor of these two, well, we've got to think of factors of 8 first. Factors of 8. Well, we could have 1 times 8. We could have 2 times 4. Okay? And those are the factors of 8. For 12, our factors of 12 would be 1 times 12. We could get 12 by saying 2 times 6, or we could get 12 by saying 3 times 4. Now, the greatest common factor that both of these have must be 4. We can look at both of our lists, and we can see that that's the biggest number that they both have in common. We're going to do the same thing when we have problems like this. If we find the greatest common factor of these, we're going to try to figure out what these all have in common. So an 8 and a 12, we know that they have a 4 in common. So if we're finding the greatest common factor of this, we're going to have a 4 out front, because that's the greatest common factor of 8 and 12. Then, if we want to find the greatest common factor of z to the fourth and z to the third, we've got to say, how many z's do they have in common? Well, they must have z to the third in common. They both have at least z to the third power. Then, how many m's, m to what power, do we have in common? Well, we've got m squared, we've got m to the fourth. They have at least m squared in common, so that's part of our greatest common factor. P. What do the p's have in common? Well, we've got p to the first, and we've got p to the second. So, we must have at least one p in common. We've found the greatest common factor of this expression. It would be 4z to the third m squared p. We could go ahead and box that and move on to the next problem. Alright, our next problem. We've got to find the GCF of 4x squared y cubed z minus 8y squared xz to the third. So let's look at our numbers first, our 4 and our 8, our coefficients. What's the greatest common factor of 4 and 8? It must be 4. They both have a 4 in common. So we're going to get 4. And then let's work with the x squareds. We'll work from left to right. We have x squared here. We have x to the first power. They both have at least x to the first power in common. Y to the third power, y to the second power. Well, they have at least y to the second power in common. So that's our greatest common factor of the y's. Z's. We have z to the first and z to the third. What power of z do they both have in common? Well, they both have z to the first power in common, so we've got the greatest common factor. It must be 4xy squared z. And we found the greatest common factor of this. We've got one more example. Okay, this one has 3 terms. What we want to do, we want to find the greatest common factor of this expression. So, 16, 4, and 2. The greatest common factor of those must be 2. They all have a 2 in common for their factors, and that's the greatest. X squared, x to the third, x squared. They all have at least x squared in common. Y, y squared, y squared. Well, they all at least have a y to the first power in common. Then, p to the third, p, and p to the 15th. Well, they all only have p to the first in common. So we get 2x squared yp as our answer. We've taken this big expression, and the greatest common factor is just little pieces of that entire expression. Lesson practice is on page 139. We'll practice this concept some more during our next class. Make sure you've got your notes completed, and I'll see you soon.